The last part of this lesson is your change of base formula. And so it says, if I have log base b of m, so a base of any number here, we can evaluate this in our calculator by using this change of base formula by doing log m, which is your common log, over log b, again, your common log. And this also works if you want to use natural log instead. We would do natural log of m over natural log of b. So example 3, use the change of base formula and a calculator to evaluate. So if I have log base 8 of 50, we can evaluate this by doing log of 50 over log of 8. So let's round to, let's say, 4 decimal places. So log of 50, and you do need to close that parenthesis there, divided by log of 8, and we get roughly 1.8813. Okay, and it's a preference on whatever you want to do, because this is the same thing as the natural log of 50 over the natural log of 8. Natural log 50, again, close your parenthesis, divided by natural log 8. We get the exact same number right there. Now, not super useful to us because we have a way of putting this in our calculator a little bit differently, to be honest with you. But this isn't a bad thing to know, because if you have something that's not a scientific calculator or a graphing calculator like this, but even one like this one here, you have a log and a natural log button. And so you can still evaluate on calculators that aren't a graphing calculator, because most of them are going to have natural log and log. Even ones that aren't scientific calculators, that are the simple ones of just add, subtract, multiply, and divide, most of them have log and natural log on those as well. But with ours, we can actually punch this in exactly the way it looks right here. If I go to alpha window, number 5 right here, log base, will allow me to put this in my calculator exactly the way this looks right here. So when I click on that, I can put whatever my base is and what it is of right there. We get the same answer. So we can use this, or we can go to alpha window, and then it's number 5 log base. I'm going to highlight this in green because that alpha button, at least on my calculator, is green. Yours might be a different color. Okay. So either way, you get the same answer. So evaluate this one. You can use log of square root 22 over log of 17, or natural log of square root 22 over natural log of 17, or just go window or alpha window, number 5, and put it in exactly the way it looks. So this is about 0.5455. Now, if you don't have an 84, if you have a TI 83, you cannot do this. It doesn't have that as a function, so you will have to use this change of base formula. Now, before I end this video, I have this little reminder here. So let's go back to property 5 on page 196. And we skipped these 2 problems here. So let's go back and solve these. If I apply this property here, it says if m equals n, which is what we have here. This is my m, this is my n. what it states is then I can add a base or a log of any base to both sides, as long as that base is the same. So you can add in a log base 2, a log base 3, a log base 4, which actually 4 would work nicely with this being a 4. You can do a natural log or even a common log. It does not matter. So if I wanted to do a common log, I could do log of 4y equals log of 17. I have done the same thing to both sides, so we are good. Now, if I wanted to solve for y, I can take this exponent and I can move it in front, where now I have y times log of 4 equals log of 17. And if the goal here is to solve for this y, this is just y times a number. If I put into my calculator log of 4, I get a decimal here. Log of 4 is a number. So if I have y times a number, the opposite would be to divide it over. So I would get y equals log of 17 over log of 4, which then I could put into my calculator. And get a decimal. So that's about 2.04, we'll say. You can see why this property here is so important. I can't solve for this when it's in the exponent position, but if I move it in front, now I can divide the rest of that away from whatever variable I have right there. Another way that we could solve this is just simply to rewrite it. If I rewrite this as a log, we go base to the other side of the equals, which would give me log base 4 of 17. And that will equal my exponent here of y. And now y is already by itself. So now we can put in log base 4 of 17, which using that change of base formula is this right here. So this equals 2.04. This is what we're going to be doing next lesson. So this is just a little bit of a teaser about how we can use these properties here to help us.